Welcome back. Today we're going to be discussing angles of polygons. So we're switching gears just a little bit from all of our trig information. So angles of polygons, we have two different theorems here. We have an interior angle sum theorem, which tells us if a convex polygon has n sides and s is the sum of all of the angles, then we have this equation s equals 180 times n minus 2. So we're taking the number of sides minus 2 and then multiplying it by 180. And I'm going to show you why here in just a minute on example 1. The other theorem is our exterior angle sum theorem, and it says if we have a polygon that's convex, then the sum of the measures of the exterior angles, one at each vertex, is 360 degrees. So no matter how many sides it has, if we take one exterior angle from each vertex, we're going to get a total of 360 degrees. Alright, so let's look at examples here. So like I said, we're going to do this first example a couple different ways so you can see how it is that we get that interior angle sum theorem. So this comes from where we were dealing with the triangles in our interior angle sum theorem. So for this one, we're going to find the sum of the measures for the interior angles for a convex hexagon. So first thing is, what is a hexagon? How many sides does that have? Well, that has 6 sides. Okay? So we're going to be making that shape and doing it with triangles, and we're going to do it with the sum theorem so that you can kind of see what's going on there. So 1, 2, 3, 4, 5, 6 sides. I have a hexagon here. So then we're going to start at one vertex. So I'm going to call this A, and we're going to start making triangles. So from A, I'm going to come across here. I can't go to this very first vertex because that's not going to make a triangle. So I'm going to go to the second one. Now I have a triangle here. Now I'm going to come from that same vertex A, and I'm going to go to the next vertex, and I have another triangle here. I'm going to do the same thing with the very next one. So I have another triangle here, and then I have a triangle here also. So I have 4 triangles. Now we know from our triangle sum theorem that each triangle is 180 degrees for their interior angles. So each one of these would be 180. So we would take 4 times 180 to get the total in there. So then if you take your calculator out, 4 times 180, you get 720, and that's degrees. Now that's using triangles. Now we're going to come over here and use the sum theorem. Now the sum theorem told us S equals 180 times n minus 2. Okay, so we're going to take S equals 180. N is the number of sides. We said there were 6 sides, so this is 6 minus 2. So again, S equals 180 times 6 minus 2 would be 4. That's the number of triangles that we had, that 4. So we're essentially doing exactly the same thing. So we get S equals 720 degrees. Okay, so that's where that sum theorem actually comes from, is building those triangles and using that interior sum theorem that we had for triangles earlier this year. Alright, so let's do another one. Example 2 here. We have the measure of an interior angle for a regular polygon is 108 degrees. We're going to find the number of sides in that polygon. So we're using that sum theorem, S equals 180 n minus 2. We're going to plug in what we know. We know that the angle measure is 108, so that's S. So 108 equals 180 n minus 2. And let's see here. This should be times n. We're taking the number of sides times, or excuse me, the number of angles times 108, which is the same as the number of sides, equals 180 times the number of sides minus 2. Okay, so let's just simplify here. So we're going to do 108n equals, distribute, 180n minus 360. Okay, we're going to keep going. I'm going to subtract the 180n from both sides. Crosses out on the right hand side, and we're left with 72n, and that's a negative on the left and a negative 360 on the right. Okay, so from here I'm going to divide by that negative 72. Those cross out, so I pull out my calculator again. So I'm going to take a negative 360 divided by a negative 72, and I get 5. 5 equals n. So how many sides do we actually have? 5 sides. Okay? So again, we took this interior sum theorem. For the sides, we had to take how much each one of our angles was worth times the number of them that we have, which was n, equals the 180n minus 2, and then we just solved that out and got 5. Alright, let's go on to another one. This one actually has a polygon on it, and we're going to be finding x. Okay, so it says find the measure of each interior angle. We have some x's going on here, so we're going to find that first. So we know if this has 4 sides, we're going to take s equals 180, 4 minus 2, okay, because there's 4 sides. So this is 180 times 2, so s equals 360. So we know the total for these 4 angles is 360. And again, we could have done that with triangles as well. I could have cut this and made 2 triangles. Okay, so we have 360 equals, and we're just going to add up all of these angles. 2x plus 2x, here's b, here's c, plus x, which is d and a. Okay, so I have 360 equals, I'm going to combine all my like terms, so 2, 3, 4, 5, 6 x's. From here, you're just dividing by 6 to solve for x. So 360 divided by 6, you get 60 equals x. Am I done? No. So I have angle A equals 60. Angle B equals 2 times 60, which is 120. So we're plugging that back in. Angle C equals 2 times 60, which is 120. And angle D equals x, so that's just 60. Now I'm done. I have all 4 of my angles. It said find the measure of each interior angle. I have all 4, so I am complete with that one. Let's do one more. For this one, we're going to find the measure of an interior angle and an exterior angle for a regular octagon. Okay, so we know that there are 8 sides, and we know that the total is 360 for our exterior. So I'm going to write exterior here. Exterior equals 360, and we have 8 of them. So we're going to take 360 divided by 8. Okay, so you can pull out your calculator if you need to. So 360 divided by 8 equals 45. And that's exterior. Okay, for the interior, we're going to use the sum theorem. S equals 180, 8 minus 2. There's 8 sides, so 8 minus 2. So that's 180 times 6. So if you don't know what that is, pull out your calculator. 180 times 6, we get 1080. 1080 equals S. That's the total interior. But I don't want the total, it just says find the measure of an exterior and an interior. That means 1. So we're going to take this total, 1080, and divide by the number of angles, which is 8. So I'm just going to divide by 8, and I get 135 degrees equals the interior. Okay, so each one of those interior angles is 135 degrees. Each one of the exterior angles is 45 degrees. Okay, so that's finding both interior and exterior. And the important thing here is this is a regular polygon. If it wasn't a regular polygon, then we wouldn't be able to find individual ones. But since it's regular, we know all of them are exactly the same, so that's why we can just divide by 8. Okay? Alright, that is all for today. Make sure that you're filling out your WSQs in the comment section, and I'll see you in class tomorrow.